Okay, so welcome to Thursday. Um, so we're going to spend most time working on the learning activity. I want to go over a couple things before we get there, so that if you finish that up, you can be done for the day when that's done. So couple things. Let's go here and wanted to cover a couple things in the learning resource effects, especially so again, we're working on a couple different things. We're working on the main textbook and we're talking about coding there, or testing, unit testing and test-driven design. And that's what we'll be looking at in the learning activity this week is some testing and stuff. I want to talk a little bit about refactoring here, and bring in the next chapter and how that relates. So our kind of time frame, just so we know, and why am I trying to get a little bit ahead here, is that we're in week 6 now. Week 8 will be kind of a midterm, and we'll have a midterm exam or quiz. It'll be an open book kind of question and answer sort of stuff for you to take. So we'll talk more about that. I have a guide out there that starts talking about next week. We'll spend some more time reviewing for that stuff. So the idea is that by we'll be done with these first 6 chapters there for that. And then do some review for that. So again, I want to get a little bit ahead for that and just bring in refactoring because of next week here. So let's just talk a little bit about refactoring. So you've heard hopefully that term before and are aware of it. So again, as a reminder, that is just when you make changes to code that don't change its functionality. You're often just making it better in some ways, making it more efficient, making it more maintainable, making it more adaptable here. Often we can talk about removing technical debt from it, poor practices you put into place when you were first grading it that now you're going to clean up and improve. This is related to testing because a lot of companies, a lot of IT managers don't want you to refactor code, don't want you to change code if it isn't adding functionality, because it's not bringing any improvement to the company, and it's introducing a pretty good chance that you'll introduce errors into your code. Don't break it if it's not, or don't fix it if it's not broken, sort of idea. And there's a whole history of that, and a history of poor software practices where trying to fix code that's not broken has caused companies, has put companies out of business, to tell you the truth here. And so one of the reasons for unit testing is that if you have these unit tests that show what the code's supposed to do, that allows you to better refactor it and then catch any errors that you may introduce or any problems that you'll introduce. So developers, one of the reasons for unit testing is developers then use that to say, oh, I'm going to refactor this code, but don't worry, we have all the unit tests in place, and those will make sure that the code, we don't break anything going forward. So unit testing and refactoring often kind of go hand in hand, that you need good unit testing to really help you with refactoring here. They talk about a certain the example. This is their account example. We I think talked about it last time a little bit. It's just like a bank account. You have a balance into this account. We're introducing a new thing, reward points. So you'll get reward points and maybe you'll spend them on something here. So whenever you add money to your bank account, we add money to the amount goes in the balance. We did that last week, on Tuesday. If you remember, we did this wrong a couple times, and now we have this. So the amount plus equals in the balance. But we do the same thing with reward points. We do some calculations for the reward points here. And then here they're calculating the reward points, and they have different types of accounts, a silver, a gold, or a platinum account here. So based on that type of account, you get different rewards for this. And they're going to use this for the refactoring. So they're going to talk about removing magic numbers here. So again, anytime you see this and you see numbers hard-coded in here, you've got to ask yourself, should this be hard-coded? Or can we pull this out into a constant to update this? You may have heard me mention it, but my favorite example was at a job I had, we had 7 phone lines coming into the phone switch, and 7 was all over our code because of that. And at some point, and there's also 7 days a week. We ran lots of reports 7 days a week. So 7 was all over for the 7 days a week. We did lots of things on a weekly basis. And at some point they were switching the hardware from 7 switches to 9 switches. And it took one developer 2 whole weeks just to change 7s to 9s every day, all 8 hours a day. Well, first he had to write reports going through every piece of code and isolating every 7 and describing what that 7 was. And if it should be, is it 7 days a week? Is it 7? Which 7 was this? And then based on that 7, should it be a 9 or, and moving it to a constant and stuff like that. So that's, you see those issues with these magic numbers in here. What are these values? And when you want to change something, where do you change it? So again, they're replacing these magic numbers with some constants here. I'm not a big fan of how they did this. I mean, they did private constants, so that's how you declare a constant. I would have, I think, liked to have seen these. In my coding sense, I like constants to be all uppercase. I just am used to that. Here, and I think they're just a little bit too long here. I have trouble with them that long. I like to have them about half this size. I think they're easy to read, but at this point, I think they're almost too, this platinum transaction cost per point. That seems like a very long. So, but again, same idea here. The other thing they talk about is replacing this, like these if-then or switch statements, with polymorphism or some other structure where you don't have to do this. And that's what they're doing here. They're talking about replacing conditional expressions with polymorphism, where you would have a silver account, a gold account, and a platinum account. Each account would define their own calculate reward points method here, and they'd all inherit from some base account for this. So there'd be some base account here, which keep the balance rewards, add transactions, but the calculate rewards would be done at each thing. So then you can just tell an account to calculate its rewards. It will know how to calculate its own rewards. You don't have to have a big if, then, else, or switch statement in this sort of stuff. So they go through and walk through this code here and sets this up. Then they talk about a factory method here, and you're going to have questions about the factory method in the assignment this week, where the stuff before this is all learning activity. At this point, we're kind of switching into the assignment. I'm going to ask you about a factory method and what this does here. So again, a factory method is how we basically it's a method that returns an object, and we can call it to create an object. And it replaces a constructor where you would just say new object of that type for this. And again, for something like this, where you want to create an account and maybe you don't know if it's a silver or gold or platinum account, or maybe you do, the question is, in your code, if you want to create a new account, and maybe it depends on the amount of the initial deposit from the customer. So you say you ask for the initial deposit. If it's less than $100, they get a silver account. If it's more than $100, less than 1,000, they get a gold account. If it's more than 1,000, they get a platinum. So you have this big expression there to do that. And so you have to be aware of all the different account types in your code, and then you're calling the constructor for a silver account or gold account. Or maybe you're just calling a general, the base account, and you assume it's going to create the right kind of silver or gold or platinum account for this. So there's different ways of doing this, and none of those aren't the greatest. So often what we want to do is create a factory package. I mean, a factory method here, like create account. Here they're specifying account type, but you can also specify, like, say, maybe a beginning balance and then determine based on that. This is generally a static method, so you don't have to instantiate this account base to call this method. Here you could just say account base.create account and specify it, and we'll give you an account base back, an account of that type back. When they talk about, here's a constructor where you say new account type, and here's the factory method where we say account base.create account. You go, well, that doesn't look that different, Tom. They both look basically identical. Ones you're just the one nice thing about this is that this will let us give us a little more flexibility on the type of account we're returning for this than the constructor itself for this and how it's tied to the account base. Particularly if we switch this rather than to an actual class to an interface and say, based on that interface, we're going to do that. Now that's a whole different thing. So this doesn't use interfaces here, but you can set it up to use an interface, and they do that later on. But I'm not going to go over that today. Okay, so that's enough on refactoring, I think, to get you started. I'm trying to wrap up all my stuff in another 10 minutes here. So the other thing I just want to mention for the assignment is in microservice architecture, particularly Docker. So we're going to start talking about Docker and Docker environments. So if you remember, Docker is this container environment. Docker will run containers. Containers are not virtual machines. They're smaller than that. So the operating system has to provide you have to provide the operating system, and then the Docker is just an environment that runs on that shared operating system, kind of. But it doesn't necessarily have to be the operating system of your host machine here. So like we can have Dockers that run on Linux on a Windows machine for that. In order to do this, we have to manage Dockers. We'll tend to use something called Docker Desktop. So if you haven't had to install Docker Desktop, you should. I, to tell you the truth, have not been paying close enough attention when I create projects, which of them have required Docker or not. So I think some of the code may have required you to install Docker already. If not, this week you will want, for the assignment, you will want. So in the computer labs here, we do have Docker Desktop installed. And running. And so if you're running on a Mac, we'll have to talk about how to set this up for the Mac here. So Michael will have to check in with you on that. Okay. And so when you create, the main thing we want to do is talk about Docker files here. So our secondary textbook talks about the development workflow for Docker apps here. So you're going to develop an app that runs in a Docker container here. So you're going to write your code, create a Docker file, and then you're going to compile the code for that Docker file. And then when you run it or debug it, it'll run inside that Docker file for that. And then go back. So again, we'll start with Visual Studio here and talk about that. And we're going to create an app that uses Docker desktop here. So they're showing you when you create this code or a new project, an ASP.NET Core Web API, you're going to enable Docker or enable the Docker here. And again, one other thing is we generally disable HTTPS. There's currently seems to be some issues. So, but you want to enable Docker desktop and select, there's generally two, your host operating system in Linux here. We'll just select Linux and create. And then when you build your project, it'll create the Docker file for you. And when you run it, it'll run on Docker desktop and it'll create a Docker image. And it should be relatively invisible to you, at least in Visual Studio for this. So, so your assignment this week talks about the factory method for accounts, that section we just went over in the chapter on refactoring here. So there's a couple of questions on the factory method or factories, and then some questions on Docker, where we want you to create a new app, do the ASP core app, and uncheck HTTPS, but enable container support there. Now in your textbook, it says Docker support, and nowadays I think the checkbox actually says container support here for that. And then you can select Linux and build the project. And then what we want you to do is take a deeper dive into the Docker file and what that is. So now, Michael, I haven't quite had a chance to run this on Mac here. So we'll have to talk. If we can't figure out, what I'll do is I'll push. I have the project already created here, and I can just push that if we can't figure out on VS Code how to create this sort of same environment. So you have to bear with me for by the end of the day, I should have that figured out. Advising week has kind of hit me, pushed me a little bit behind on this. Okay, so let's start. Let's go back to well, first, any questions on that before we go to the learning activity? So learning activity is just go to this account, start the assignment, clone that assignment, now, just wondering, what I used to have students do is create a user interface, a graphical user interface for this, like front end for this account stuff. And we used to do it in Windows Forms, and you can still do it in Windows Forms, but Windows Forms is just really old now. So I've decided just to get rid of that and just have you do it on a website. And that lets you do it in any sort of environment, Mac, Windows, sort of environments. And so I've actually created with Razor, actually this is Blazor, I think, a website, but this user interface, this basic user interface here. So this first, it just talks about the code here. So if you go to your project, go to, so there's www.root, and you'd think your stuff would be in there, but it's not. It's in components. So components are the things that the root uses in the current setup for this type of app. And then under pages are your pages. Under home is your home page. for this. And it might make sense to run this first. It should run. Out of the box with just a couple little errors that you will need to fix as part of the assignment. So again, this is an account, so I can create an account here. So I'm going to create a Tom savings account and add that account. I can add another account. Maybe I want to Cami vacation account. I can select the different accounts from this list here. I can add money to an account. Add it again. Withdraw doesn't work, but if I switch from one account to the other, I can kind of see things. The account balance isn't always updated when it should. I mean, the display isn't always updated here. But if you deposit or withdraw, it updates the balance right now. So it's certainly not a perfect account system, but again, you can kind of switch accounts and see things. So that's where you're starting. So go through, start looking through here. Try it out. Again, we click on the account box. It should list the accounts. The deposit button should add amounts. The withdrawal button is not working there. So now you can go through, start doing your questions. It asks you about some of the code in here and what it does. And then we do this TDD, test-driven design. If I run the tests here, where's my test explorer? Over there, I guess. I will get a number of tests. Almost all were related to withdrawals failing here. So there's 2 there, and there's a whole bunch there. So your job is to get the withdrawals working. So you'll have to look at this code. It matches what's in the textbook. And so if where we have under domain, we have our account base, and now we have a gold account, a platinum account, a silver account. And then under services, we have account services here and an interface to the account services that we use. Okay, so work on that, and I'll answer any questions as we go. So one thing that I'm interested to see is that I'm trying to have you look at code you've probably never seen before and see how well you can understand it there. So feel free to use AI. So again, this isn't a bad place to bring up AI, paste the code in here, and ask it. So although I want you to, generate a description, I don't care if you use AI to help with that description. Make sure then you read through the description AI gets you and make sure you understand that if you didn't understand the code initially there. So. Okay, I was asking for this question 4, can you determine where in the top HTML code does the method get called? So this is this button deposit click method. Where is that? How is that called? And so when I say a top HTML code, I wasn't really clear on that. In this home.razor file, which we're looking at here. So it's in components, pages, home.razor file. It's divided into 2 kind of parts. The top part is all HTML with some C# inside. So anytime you see an @ it has some C# code, but most of it is HTML code. And then the bottom, we start at code. And then this is all just C# code. And this is where the button click is. So my question is, where is this called in this top half, the HTML code up here for this stuff? And you'll see, you should find somewhere where it's called in that top HTML code, some reference to that button click event, or what the button deposit click event or method will be called up above somewhere. Okay, that makes sense. So I see quite a few, I think, are moving on to this test-driven design and getting withdrawals to work. So just to, if you've got that figured out, don't worry, you can ignore me, but here's a quick overview. So in account services here, so under services, account services, there's a deposit method and a withdraw method. The withdraw method we haven't coded yet. It just throws an exception not implemented here. So you should look at the deposit method and do something similar for the withdraw method here. There's a number of options on how you want to do this here. They all will use the account base. So again, this finds an account in account base, and we have an add transaction there for that. You specify amount, so you can determine if you want to just send a negative amount to the add transaction, or if you want to have another, withdrawal transaction or something, or subtract transaction there. So you can figure out how you want to do it, but we just want to get the withdrawal to work. Remember that also when we do this add transaction, we're calculating reward points. You only get rewards when you deposit money, not when you withdraw money. So however you set it up, you should only get money rewards when you deposit, or when you add a positive amount there. So once you get that all figured out, hopefully all your tests will pass and you can move on to the refactoring phase of this. Okay. So one last thing that eventually you should get all your tests to be passing. You want all your tests to be green there, and then you can go on and look at refactoring this. Is there some part of it that you want to change? Maybe when you're going through the code, you just saw something, or maybe the code you put in wasn't so great there. There isn't much error checking in here. There's some problems with the GUI not updating here. Also, there are 3 different account types. The GUI only lets you create one account type. All accounts are silver accounts. So again, you can just pick one of these fixes to thing. The one I think is more common is that the way I fix this is that my account services simply, I just duplicated the deposit account and multiply it by -1 there. And then I just use this account add transaction here. But then I put in a thing for the add transaction that if the amount is negative, or only do rewards if amount is positive, basically. I think now after doing this that it would be better to have an add transaction as a subtract transaction and set that up so that withdrawal used it as subtract transaction. So again, I can rework this, fix this, and do this. Now, one thing that I will let you do is modify some tests if you need to here. So where are the tests here? Just so you know, there are 2 different projects here, and this is pretty common. One is our main account project, and then the tests are in a separate project here. There was domain tests and service tests here. And again, in the service tests, they will do things like maybe withdraw negative amounts. So here we withdraw a negative amount or something. So generally you shouldn't have to change your test, but again, if you're adding some methods or something like that, you might want to look. You are allowed to do that if it's for a specific reason, other than just to make the test pass. You shouldn't necessarily edit tests just to make them pass. Okay.